Good afternoon friends, and in this video we are going to discuss about the integration by parts. Since we are again into the series of the integration, so we have around 19-20 videos we have already made about this integration. In this video we are focusing on the integration by parts. So without wasting much of your time, let's come back to the task. So it goes like, the rule goes like that: integration of uv dx, where u and v both are the functions of x and they are integrable. So it is u into integration of v dx minus integration of du over dx v dx dx. So the integration of u v dx is u integration of v dx minus integration of the product of the differential of the u du by dx into integration of v dx. So if you say that the u is the first function, then we can write in our words like integration of parts. So this you can take it as the first function. So this first function remains unchanged. So first function into, this is integral of second, the first function into integral of second minus, this is integral of product of the first function and integral of second. So you write here integral of product of differentiation of first function into integral of second. This is the rule in the world. Now, how to find which one function is the first function and which function is second function? Rule says that isolate. So rule says that the order will be based on this rule which says isolate. I means inverse trigonometric functions like sine inverse x, cos inverse x, tan inverse x, etc. And the log, L is the log function, log x to the base e. A is algebraical function like x, 5x plus 7, x square or 7, that is constant. T is the trigonometric function like sine, cos, tan, cot. And e is the exponent like e to the power x or a to the power x. So this is the order, like when your function is the product of the two functions, like suppose, for example, suppose if I have integration of x e to the power x dx. So the rule says that x is algebraical, that is a, and e to the power x is exponential e. So a e, it means a comes first, so a will be your first function, so that is your u, and the e will become v. So this is your first function, this is your second function. When you have suppose integral of x to the power 3 sine x, so this a is algebraical, sine x is trigonometrical, so at. So at, so a is first, t second, so this is your u and this is your v. So on the basis of this expression isolate, we will be determining which function is our u and which function is the v. And the u is our first function, v is the second function. So again I would like to summarize the whole rule in one line. It says that integration of uv dx is integration like u. So integration of uv dx is u, means keep u unchanged, into integration of second minus integration of product of, this is, these two are product. So integration of product of the differential of the first and integral of the second, again both with respect to x, or in the words you can say integration of the two functions, first function and second function, as first function unchanged into integral of second minus integration of the product of the differentiation of the first function into integral of the second function, and then again you have to integrate this whole thing again with respect to x. Now I take some examples. So here I have a form like I is integration of x cube sin x dx. So you see that x cube is algebraical in nature, that is a. So this will be my u and this is my phi. So rule says that first I have to keep this x cube unchanged like this. So x cube as it is, integration of sin x dx minus integration of, then you put a curly bracket, integration of, now differentiation of the u which is unchanged there, x cube into integration of sin x again dx, and this whole thing will be integrated again. So here you see this becomes x cube, integration of sin x is minus cos x minus integration of this is 3x square and minus cos x dx. So you find that this is done, but this part is again it can be integrated, and the same style, x cube minus x cube cos x plus 3 outside, I write it as x square cos x dx. So again I have to use the integration by part because x square is algebraical and cos x is trigonometrical function. So that again it is minus x cube cos x plus 3, I put a box bracket here, keep x square unchanged, integration of cos x dx minus integration of d by dx of x square into integration of cos x dx and then dx. So this is minus x cube cos x plus 3, and integration of cos x is sin x. This will become 3x square sin x and then minus 3, integration of this x square's integration is 2x and this is sin x again. So we need to integrate this term again, it is 2x sin x. So again we need to integrate it one more time. So I think that, can I write one more line? Okay, so I write here only. So it goes like this, that this is minus x cube cos x plus 3x square sin x minus 3 to the 6, and let me make this one smaller, then integration of x sin x, to keep x unchanged, and integration of sin x I can write directly as minus cos x minus integration of differentiation of x, that is 1, into integration of sin x, that is minus cos x dx. So this is minus x cube cos x plus 3x square sin x. Now this will become plus 6x cos x. This will become plus and this further becomes minus, and then we have to find the integration of this cos x, that is sin x. So minus minus plus again minus, so minus 6 sin x plus c. So this is the answer for this question. So now I take one more example to clear the idea. So I take another example and this goes like I is x e to the power x dx. So this is a and this is e. So order is perfect. A is your u and phi is your e to the power x. Then what will do? That keep x unchanged, integration of e to the power x dx minus integration of differentiation of x into integration of e to the power x to be differentiated again. So this is how it goes. X e to the power x dx integration minus integration of product of d by dx of x and into e to the power x dx again. So I now write e to the power x minus differentiation of x is 1 and integration of e to the power x is e to the power x again. If you differentiate, you'll get your answer as x e to the power x minus e to the power x plus c. This is done. This is how this question can be solved. So now I take another form where it goes like integration of log x to the base e dx. Then what do? You need to introduce the one function that will be algebraical in nature and does not make any difference in the quality of this question. So it can be integration of 1 into log x to the base e dx. Now this 1 is kind of algebraical function, it's constant function, and this is your logarithm function. Then we have isolate, so it means this one should be your u and this is your v. So what you need to do, that keep log x to the base e constant, integration of 1 dx minus integration of differentiation of what was unchanged, that is log x to the base e into integration of 1 dx and then dx again. So here you see the integration of 1 dx is x, so I prefer writing here first. So x log x to the base e minus differentiation of log x is 1 over x and integration of 1 dx is x dx. So this one gives you the integration of 1. So x log x to the base e minus integration of 1 is x dx, because you see x and x is just 1. So this is just x, and then here you introduce the idea of constant of integration. So this is your answer. So integration of this is just this. Now let me take one more form. Now I have a question which goes like x square log x square plus 1 dx. How can I find the integration of this form? Again, the log is the higher priority, so we say this is my u and this is my v. So now I'll write log x square plus 1. I'm not writing the basis, however actually the base is e. So the log term, log x square plus 1 to the base e unchanged into integration of x square dx minus curly bracket d over dx of log x square plus 1 and into integration of x square dx, and this whole should be integrated again. So now this one equal here, integration of x square dx is x cube over 3. So I write here first x cube over 3 log x square plus 1 minus integration, this is differentiation of log, this is 1 over, this is log something, so 1 over x square plus 1 into differentiation of this something, that is x square plus 1, this is 2x into integration of this, which will give you x cube over 3 dx. Now all these things should be integrated again. So this is x cube over 3 log to the base e, that is x square plus 1 minus 2 over 3, I take it outside, this is 2 over 3, and this becomes x to the power 4 upon x square plus 1 dx. Now this is not integration by part, this is normal way of solving this question. How can you solve this one as integration of x to the power 4 over x square plus 1? So now how to find? So here I just tell you, I'm just doing this one separately. So I is I1, I call it as integration of x to the power 4 over x square plus 1 dx. I write a separator here. Then you can write this whole thing as x to the power 4 minus 1 plus 1 over x square plus 1 dx, and this becomes x to the power 4 minus 1 over x square plus 1 dx plus integration of 1 over x square plus 1 dx. Now you see integration of this, you know this a square here, so a square minus b square, and this is a square plus 1. So a square x square minus x to the power 4 minus 1 can be written as x square minus 1 and x square plus 1. So if I cancel this one directly, so here this one, first let me factorize, this becomes x square minus 1 times x square plus 1 over x square plus 1 dx plus 1 over x square plus 1 dx. So this cancel, this and this, we have to find integration of this, that is x cube over 3 minus x, and this is just tan inverse x. So this is the integration of the term I1. Now our question is that we have this part, this answer, this minus 2 by 3 of this is I1. So we write our whole answer here as this one. I'm writing it red so that you can identify. This is, so I had to write this first term, that is x cube over 3 log x square plus 1 to the base e minus 2 by 3 times, minus 2 by 3 times whatever we have found here, that is x cube over 3 minus x plus tan inverse x and then c. So now if I dissolve the bracket here, it's minus 2 by 3, this become bracket gone, this is minus 2 by 9, 2 by 3 into 3 is 2 by 9, and then this minus 2 by 3 will come here, to become plus 2 by 3, this also becomes minus 2 by 3, and this is your final answer. So this is how this particular question can be solved. So this is how the integration by parts questions can be solved. So in the next video we will take some more examples, and some different forms also are there which are based on the integration by parts. Thank you very much. Just watch our video and keep practicing.